Okay, so what we see today, we're going to be looking at volume. Like yesterday, we talked about volume. We learned volume of shapes. As in what I mean shape, like a cube. We learned prisms. We learned pyramids. We learned volume, like how much space is in something. I mentioned about like a swimming pool, how much water is in the swimming pool. Right? It could be any shape, how much space is inside. However, there's not shapes that are not that nice to measure. Imagine a little screw, or imagine a key. I'm going to do number 44. Imagine a key. The way we're going to be doing this, the way we're going to be able to find the volume, scientists decided that they're going to be able to measure using water. So I have these little things here. On the left side, you guys notice that my cube, the what I'm measuring, in this case, my screw, it's outside. So I measure how much water is before I put my screw in there. Make sure you know how to count these measurements here. It looks like it's here and it's 150 milliliters. I'm just gonna look at the number, so it's 150. By the way, for you guys to know, we use grams for weight or space, how much the volume of it, and we use liters for liquid. So I'm going to be using liters because I'm using liquid to measure how much space is in this little screw. So when it is empty, when the screw is outside, my water is at 150 milliliters, right? I can see that there. Now, when I put in the screw in there, it goes right here. All right, gotta count how many spaces are there. I noticed that from 150 to 200, there's 10 little spaces. So I'm gonna say each space is 5, right? Each of these little spaces, when I said each of these spaces, I mean this much. That's 5, right? So it looks like that is 180. All right, so once again, let me say, without the screw, the water was 150 milliliters. With the screw is 180, right? With the screw is water plus the screw. So here it says find the volume in milliliters. So I'm gonna say, all right, this one is 30. I subtract the two values, right? 150 is this thing empty, no screw in it, just the water. 180 is water plus the screw, right? From 150 to 180, he went 30. That's it. So the volume of my screw is 30 milliliters. Now let's take a look at the key. Let's take a look at number 44. When the key is outside, my water is at this level, which is 50 milliliters. I know that from 50 to 60, there's 5 lines. So I'm gonna say each line is 2. Right, if you guys notice, from every 10 milliliters, there's 5 lines. So every line means 2 milliliters. All right, so empty, just the water is 50 milliliters. With the key, it's at 60. The difference between 50 and 60, so I'm gonna subtract those. I'm gonna say the key in this case is 10 milliliters. I'm just gonna write the number 10. That's it. So you guys can use these containers to find the volume of anything, right? Weird shapes. Same thing, we can use cubes, right? This looks like a fish tank. Not gonna recommend you guys put things inside a fish tank. You might contaminate the water, but we can use them. We can use it to find the volume. Now here is just find the volume in cubic inches. All right, so I'm gonna see how much water did it change, and round your answer to the nearest tenth if necessary. All right, so we're gonna multiply. I'm gonna get a decimal, and I'm gonna round it to 1 decimal place. All right, so what I'm looking here, it looks like there's a fish tank I see the measurements of the fish tank are 35 inches by 12 inches, right? I see the base of the fish tank is 35 by 12. But the measurement at the side, 1.3, what I have that is the change of the water. So I had the water at a certain level. I put that white thing in there and it changed 1.3 inches. In reality, if you think about it, imagine there's the base. I'm using the dotted line so you guys can imagine there's on the back. It rise a certain amount of water. It looks like I'm looking at a prism, right? If I'm looking at the change of water, it looks like I'm looking at a prism. And I remember yesterday, prisms, I said the volume is the area of the base times the height. So the base in this case is the rectangle at the bottom. I'm gonna go 35 times 12, right? That's the base. The height in this case is 1.3. That's it. I'm looking at how much water difference there was, and I'm just looking at this as a prism. So I'm just gonna go 35 times 12 times 1.3, and it gives me 546. If there is a decimal, I didn't get a decimal, but if there is a decimal, round it to 1 decimal place. Same thing, we can measure fishes. Let's say I have a fish tank now that is 13.4 by 6.2. When I look at my measurement here, it's 13.4 by 6.2. And it rise, the water moved up by 2.1 inches. Let's imagine there's the back. So I'm looking at a prism. You guys are very, very curious how big your fishes are. Do this. Measure your fish tank, put the fish in there, and you guys are going to see how much the water changed. So again, I'm going to say my volume of this fish in here is going to be area of the base times the height. The base is a rectangle. It's a 13.4 by 6.2 inches. That's the base. The height in this case is 2.1. There's a bunch of decimals, so I actually am expecting a decimal answer. So I'm going to go 13.4 times 6.2 times 2.1. My calculator says 174.468. All right. I said earlier, if you have a decimal, rounded to the nearest tenth. So I look at the second decimal number. It is big enough, so it's going to push that 4 over. So my answer will be 174.5. As a matter of fact, on the instructions, I'm even saying find the volume in cubic inches. So I want you guys to remember it is a prism where you're looking at area of the base and how much did the water rise. So far, so good. Volume, I'm not quite done yet. When I'm looking at milliliters on questions 43 and 44, I'm just looking at how much did the water rise, right? How much was it just the water? And then how much is the water plus whatever I'm measuring? How much did it rise? Now here in cubic inches, I'm considering the whole thing, the whole base times the height. Area of the base times the height. And the height, when I say height, is how much did the water rise? Now, I know for my example, I wrote my numbers. Some of you guys might be like, holy smokes, Mr. Leonzo, a 13.4 I can read. The 6.2, that's kind of hard. I know I don't have the best writing in the world. So in your homework, in your quiz, I type the numbers. So don't think that, oh man, am I going to have to read this chicken scratch? No, it will be typed. My son has a better writing than I do, and he's only 6. So it's all right. It's okay. Now, the last two questions of this year, the semester, we're going to look at density. So let me use the word density. Now, density is how much, like if I use cardboard, how much cardboard is there in a small space, right? Imagine if I gave you guys a box, cardboard. I gave you guys a box, and then I said, all right, guys, this is your desk. We put it on you guys' laps or somewhere, and write on it. Put your papers on it, and this is gonna be your desk. I gave you guys a box. More likely you guys will struggle, right? The box is gonna break. Like you're gonna. It's not gonna be that hard, right? The box is gonna be very, very soft, and it's not gonna help you guys out much. Now imagine I came over with a bunch of boxes, and I pressed them. I pressed them together. Right? I had a bunch of boxes, and I smashed them to make them all fit in a small space. I know you guys have seen such case because I know you guys have gone to a classroom and you guys have seen a desk. They're not made out of wood. They're made out of cardboard. Right? What they did is they got a bunch of cardboards and they pressed them together. The density, right? There's a lot of cardboard in one space. The desk in your classrooms, you guys have seen them, they're kind of hard. If I have a small amount of cardboard in a space, like I said, imagine I give you guys just a simple box, right? It's too soft. So density helps it make it look like, makes it stronger, right? It could be anything. It could be feathers. I could put feathers and make them hard. Like if I had a lot of feathers and press them, it could be condensed. So it could be the densities makes it hard. That's what density is all about. The way we're going to find out density, we're going to go mass. Mass is basically how much does it weigh? Mass divided by volume. And again, volume is how much space does it take? Usually grams is the measurement for mass. So I'm going to write grams. Grams is the measurement of mass. Sometimes we use pounds, right? How much does it weigh? And volume is how much space does it take? For today's purpose, we're going to be mainly using liters. This is basically the measurement to measure liquid. But as you guys notice, I can measure volume with liquid like we just did a few minutes ago. So mass divided by volume. Some people say that it looks like a heart, mass divided by volume. Because if I write mass as an M and V as a volume, you guys can see that density is mass divided by volume. So think of it as a heart. Later on, like right now, hopefully you guys are writing down the formula. But what about a few years from now? Oh crap, what's the formula for density? Mass divided by volume. Think of a heart. Okay, so let's take a look at number 47. A block of aluminum occupies a volume of 15 milliliters and weighs 40.5 grams. What is the density? Okay, so I have somebody here that gave me the answer. We'll see. So it's mass divided by volume. Right, I'm going to write mass divided by volume. The mass, like I said, I'm going to be doing grams. So 40.5. The volume in this case is 15.0 or just 15. I'm just going to go 40.5 divided by 15. And it gives me 2.7. In the chat, somebody has said, is the answer is 2.7? Yep. Mass divided by volume. Let's take a look at number 48. 28.5 grams of iron shot is added to a greater cylinder containing 45.50 milliliters of water. The water level rises to the 49.10 milliliter mark. From this information, calculate the density of the iron. All right, so I'm just going to go mass divided by volume. Mass, I can see that it's 28.5. So 28.5. For volume, I see two measurements. You see two numbers. So it seems like there was water. The container was empty at 45.50, right? It had water at 45.50. Once I added the iron, it rise to 49.10. For us to imagine what I'm looking at. So when it was just the water, it's 45.5. When you had the iron, it's 49.1. Didn't we just did that at the beginning of today? For me to find out the volume, let me subtract those two numbers. 49.1 minus 45.5. So I'm going to say the volume is 3.6. You have to calculate the volume, right? As a matter of fact, on your homework, I even going to give you guys a question that says, the container by itself weighs this much. The container with just water weighs this different much, but the container with a rock, so I'm going to give you guys three measurements, three weights. You're interested in how much the rock weighs, so make sure you guys pay attention to that. All right, so now on this one, 28.5 divided by 3.6, it gives me, according to my calculator, I'm going to round it to one decimal place. It gives me 7.9. In reality, gave me 7.91 and a bunch of sixes. 7.9. This is how we do density. Now, I hope you guys are curious. Like curiosity, hopefully it's one of your gifts. You guys want to measure the volume of something weird? Now you guys know, right? Use water to be able to measure. Use cubic inches or use just liquid or liters. So I'm hoping you guys are curious. All right, let me zoom out so you guys can see the notes. Let me stop the recording.